Hello, everyone. Thanks for joining the call and happy International Women's Day for all the women in tech in the call. My name is Meena. I work as a partner solutions architect in AWS, which means that I work with machine learning partners predominantly and onboarding them onto AWS, either as a SaaS platform or building deployment accelerators to get it deployed for multiple of our customers. It's my pleasure today to welcome my colleague Mahesh, a data analytics expert, to this discussion. Mahesh, would you mind providing a brief introduction about yourself?
Sure. Thanks, Meena. Sure. Thanks, Meena. Just now, and as Meena said, I work primarily in the analytics and serverless space. So again, welcome to everyone to the session, and special welcome to all the women and happy Women's Day.
Okay, Mahesh, given you are in the analytics space within AWS, we hear a lot from our customers around, data-driven organizations. And as we see that, the data is increasing at tremendous capacity. And what is AWS doing in driving customers towards a data-driven organization?
I think that's a great discussion, Meena, right? So I think the way we look at it at AWS is in a three-facet manner. The first, starting off with modernizing your data, right? So what we basically mean by that is taking your data elements that you have and building them to scale, right? So a good example could be if you are having some kind of relational database to store your OLTP kind of data, you are going to hit a bottleneck at some point on premises because of the capacity issues, but you want to design your applications to scale because more and more data is coming into the system, as you said, not just relational, but also all other types of data, right? So that is where we start to think about more of it as a modernizing tool. And the other way we look at it is unifying, right? So especially when you look at enterprises, you have these multiple silos that are spread across, or the data that is sitting in different areas, in different warehouses for different reasons, right? So it could be compliance, it could be teams do not collaborate, or the projects are not thinking about it. So the other way we look at it is unifying all of this data that you already have and also interacting with newer data elements, because getting new data has become so cheap and so easy these days. You can also think about getting external data and starting to unify all these different data elements and starting to gather intelligence, starting to gather analytics out of it, and also thinking about how do I take all this data together and build something like a customer 360, right? For example, a good use case could be our customer could be interacting with you on your web. He could be making transactions on the call center. He could be having some problems. He could be doing a lot of searches on your web. So when you try to take this customer and view that 360 degree, there is a totally different perspective you can get, and you can be even proactive in most of the scenarios, which leads me to the innovative, right? So if you look at it and you now say that, okay, I have all this data, I got all of this, I'm unifying, I'm seeing the customer behavior and being innovative in the sense of trying to predict what that customer will do in the future could be a very important insight that you can provide, right? So a good example in a retail could be a customer does not like certain colors. So even showing them show important. And so when you put all this together, Meena, I think it is what we call the modern data strategy, is trying to take what you have, modernizing it, trying to also unify, trying to see what are the other elements along with this data that makes sense, and trying to club all of that together, and at the same time thinking about AI, ML, and building innovation on top of that.
Awesome. Thanks, Mahesh. So clearly, AWS has defined a strategy across three pillars around modernize, unify, and innovate.
Sure.
You talked a lot about modernizing, which includes management of different types of data structures. Right now, you talked about a little bit around structured, unstructured, all sorts of data. I'm quite intrigued by how AWS is unifying all these data into some sort of a data lake or whatnot. And I also want you to touch upon some of the stuff around lakehouse. I mean, a lot of our customers are asking us, there is data lake, data warehouse, and there is data lakehouse. I mean, can you make sense of some of these things and how AWS is driving customers towards unifying the data to drive more insights into the data?
Yeah, sure, Meena. I think the way we want to look at it is in multifaceted way, right? We will talk about it like the warehouses. Every enterprise today has some kind of warehouse for their data, right? They might be storing it in something on-prem, or they might be using some form of cloud to store their data. And that is a traditional warehouse where you are more like questioning what happened yesterday, right? So if you think about a data warehouse, you are kind of looking at history and trying to have this a trend that is going on. This is from previous. For that data to happen in a warehouse, it should basically have lot of different things, right? It should be structured. It should be perfectly fit into a specific data model. And the problem with that we see is there is with new data being generated, there is a lot of data loss between the time the data is generated and the time you fit it into the warehouse, right? So that is where we kind of we saw that there is a lot of gap there because you're losing a lot of data, which is not ideal. And also you have these two different types of data which is not traditionally put into any kind of warehouse, right? A good example could be a call center data itself, right? So the call itself has a lot of data, right? The call has that audio recording, which is immensely helpful if you are able to convert that into some form of data which you can start to do analytics on, right? And the same with images could be again a huge thing. And as you know, a lot of businesses today as well, business side of the organizations rely heavily on Excels and stuff. So there is a lot of data even in that semi-structured format and unstructured, as I said. So what we look at it is that is where we talk about data lakes, right? Where not just the warehouse data, but trying to expand that to store semi-structured data, trying to store unstructured data as well, and start to start to think about how do we deliver value or how do we deliver insights out of that, right? So that is what we call data lake. And the center of our entire data lake architecture at AWS is Amazon S3, which basically is our storage, scalable storage. And few things we look at, especially in the lakehouse architecture, Meena, is things where as data is growing, as new data types are coming in, as new vendors are participating in your are partnering with you, you will have more data. You will have different types of data. Today it could be JSON, Parquet. Tomorrow it might be something. So you want your data lake architecture to be something that can be flexible. So as part of that, we also want to have tools where you can have this data movement, right? So if you have one type of format that the source system is coming in, the data warehouse might still need it in that CSV format, the source sending, but your analytics team might need it in a more of a Parquet format, right? So you want to make that integration seamless and easy. And that is where I think AWS brings in not just one solution for one piece, but it brings you that overall picture. As you can see here, is we have the S3 at the center, and also Athena is where you can actually query the S3 flat files using a SQL-like interface, which I think is amazing because we have so many SQL experts in different companies, so you don't have to learn anything new. And then we have Glue, which helps you with transformation, and we also have Lake Formation, which is kind of sitting over all of this, which is kind of your data lake, or which is kind of your data lake of just enabling the data lake formation feature will really help you. And outside, if you see, we go with what we call purpose-built databases, where if you see Redshift is our data warehousing offering, Aurora is AWS's relational database offering. We also support MySQL, Postgres, Oracle, and even SQL Server if you have, right? You can just get that into what we call RDS. And we basically, that is really useful because now you don't have to completely transform your data. You can basically get as is and then start to modernize. And also we have tools to integrate and transform. Glue is our integration and transformation. If you have something related like Hadoop, you have EMR. I think again that is huge. If you have something with NoSQL, we have DynamoDB. Amazon's DynamoDB can scale up to millions of writes per second, and a lot of big companies use that, enterprises use that. And we also, at the end, again, we want to tie all of this together with the ability to do artificial intelligence and machine learning is where SageMaker comes into picture, right? And that way now you are not just having one tool, but you are now having that ability to make choices on what is the right tool for this kind of data and process it accordingly and deliver insights and also machine learning from that.
This is awesome, Mahesh. Thanks for providing a deep dive on the key services that revolves around the data lake and which kind of forms the data lake house in general.
Sure.
So often we take pride in saying that Amazon is more of a builder's paradise, and you have a bunch of solutions that you can build with a lot of our services and everything. With this kind of an architecture, I can clearly see that there is a whole lot of data movement back and forth from the data lake and to the rest of the data services and whatnot. Can you go a little bit deeper into what AWS is doing in terms of bringing in some sort of reference architecture or all the services that you might want to think about in driving towards me for the customer to start with their data lake journey?
Sure. So as you pointed out, right, Meena, we have about 220 different services. And again, the reason we have so many different services when I talk to customers sometimes is we actually do it more like purpose-built structure, right? What we mean by that is, as you can see, we have, I think, 5 offerings on the slide here, but we have about 13 different databases that you have, right? We have one for graph, we have one for blockchain, we have one for time series, and we have a couple for relational databases. We have our own Redshift, which is our warehouse, right? The reason we have that again is we want to make sure we have the right tool for the right purpose. And most of the time, especially when you talk about things like Graph or things like Redshift, the hardware behind these is not something that is very generic, right? Because we also control some of the hardware on the types of chips that we use. We have Annapurna, which helps us make our own chips. We basically purposefully build this hardware to support some of these, right? So I think that is one of the biggest difference if you're thinking about it. Now you have on hardware, you have the software and operating system, which are sitting on top of it, which are exactly tuned for that specific use case that all of us are aiming for in case of Redshift, right? Again, if you have streaming data, again, we have these specific things, specific hardware, which is tuned for kinesis, video streams and stuff like that, which I think is really huge if you think about it, rather than having these daemons in the operating system, which are continuously running in your servers, which really it doesn't really help you much because it is generic. And trying to purposefully build, especially at the hardware level, and having that ability to use some of the hardware capabilities, I think is going to be extremely huge. And that is how Redshift actually achieves like 10x performance compared to a lot of industry leading database providers in the cloud, right? So I think that is huge. And again, when you talked about integration, right, moving the data is extremely important. So you want a tool where you can take one form of data and basically change that into different forms of data. At the same time, you also want it to have that, you don't want to lose the data. You also want to have that ability to have some data insights right out of the box, right? Rather than transforming that into Parquet and doing all of that. You want that analytics right out of the box, because the moment the data is generated, it is more valuable, and as time goes on, the value of the data goes down, right? So we have multiple tools, especially in the Glue schema of things, right? Glue has multiple things in it where you can do all of these, right? Elastic Views has been something we announced recently, which is, for me, I think, which is huge, where you can take the same data and have different views on that, right? One could be for data warehousing, one could be for machine learning and stuff like that. And I think, again, as people talk more and more about the data lakehouse architecture and data warehouse, one thing you want to always put in mind, as you know, security is job zero at AWS, right? How do you govern all of this data that is coming into your warehouse or the data lake or the lake house, right? That is where I think lake formation will make a huge impact, especially if you're thinking about governance. We have something called govern tables, and a lot of those we can definitely dive deep. And these are all amazing features that we are giving to the customers, but at the same time, cost and performance is extremely important. So that is where I think we stand out completely, because again, you go with the same pay as you go model. At the same time, we also have automatic recommendations. We also have a lot of performance tunings that are built into pretty much most of our managed services, especially Redshift. As I said, we have something called Aqua, which your performance is by default increased by 10%. There is nothing the customer has to do. It is just a checkbox. They say, okay, I'm fine with having data cached. And now you have this amazing capability. So when you look at it overall from a journey perspective, all the way from producing the data to driving analytics in a very cost efficient, performant manner, I think is where we make a huge difference compared to others. And as I said, we have so many different services and specifically, and I know I wanted to ask you about specifically machine learning, and with all this data insights, right, Meena, how do you think primarily we can drive machine learning, or like have been hearing a lot of customers talk about democratizing artificial intelligence, right? So how do you take that into that next step? I know you're a machine learning expert, so just wanted to get your thoughts there and how AWS helps there.
Absolutely. Yeah. So when we start talking about democratizing AI, it is about making AI available for different personas within the organization. So obviously, if you look at the data space in itself, you have business analysts, the data engineers, the data analysts, machine learning engineers, and data scientists. A whole lot of people working in this space. But how do we make this machine learning available to everybody within this organization, to different personas? Is all about democratizing AI, right? So we have been innovating on behalf of the customer to develop and deliver the broadest set of tools and technologies to drive this democratizing AI phenomenon. So what you see here on the screen is AWS's machine learning stack. If you look at the stack, there are 3 layers in the stack, and each of these layers are confined to a specific set of persona within your organization. Let's drive from the bottoms up. At the bottom of the stack, we have the ML frameworks and infrastructures. Think of these machine learning practitioners within your organizations who wants to build their own set of neural network architectures, develop machine learning on their own set of frameworks and everything. This is where they start within the SageMaker, right? So they can bring their container, they can bring their framework onto machine learning, onto SageMaker, and they can start building on top of SageMaker. The other one that we have is, the extensive list of compute capacities for running different GPUs, for specific instances for training and inferences, all available for you in a click of a button. When you go up one level within the stack, that's the middle layer of the stack is where the ML services. Think of your data engineers and data scientists who wants to build an end-to-end model development lifecycle within AWS. SageMaker plays a huge role in this play, right? So if you think about building an end-to-end machine learning lifecycle, you're starting with preparing the data by connecting to your data lake or a data warehouse, and then starting to build features, training the model, tuning the model, and deploying the model. And it just doesn't stop with deploying the model, but also you'll have to monitor the model post-deployment and everything. All of these things, an end-to-end machine learning lifecycle is provided to the customer in a single pane of glass using Amazon SageMaker Studio. Last year reInvent, we also introduced 2 more services, which is SageMaker Canvas and SageMaker Studio Lab. So think of SageMaker Canvas as a low-code, no-code ability to build machine learning, right? So the level of expertise that is required for you to use SageMaker Canvas is more about a data analyst or a business analyst expertise. You can plug your model, you can plug your data in and build model without any machine learning expertise using Amazon SageMaker. When we come to the top of the stack, this is where we have AI services. Think of AI services as readily available machine learning models, already pre-trained models available for you to use by calling just an API. So for example, you are building an application, and in that application, you have some text that is coming in and you want to get the key entities or identifying a sentiment from the text and whatnot. As a developer, you have very limited capability on machine learning and you're more focused on application development. But with these AI services, you can call these AI services, these are pre-trained models available for you to be called, and you can start getting the topics, the entities, the sentiments, the PIIs, and so on and so forth. What I talked about is one such AI service, but there are so many AI services that are out there which are covering from text to videos to chat and vision and whatnot. And this thing is just increasing by the day. We've also taken these services and making it more industry-specific services now. And as you see that there are specific services that are very focused on health lake, specific services on industrial, and more services on IT and whatnot, right? So this is how AWS is looking and working with the customers and identifying the needs and driving, democratizing AI across different personas within the organization.
Thanks, Meena. I think that kind of gives me a really good understanding about your layered architecture and how. And when I look at it, especially in the ML space, right, I see a lot of customers having a lot of data today, right? They have generated the data either through the warehouse or capturing the data or buying data from external companies. And you talked about SageMaker Studio, and Canvas being something with low code, no code, which can be something easy to start off with. If you don't mind, can you dive deep a bit more into that SageMaker and how a customer can start their journey on SageMaker and start to see some insights into machine learning?
Absolutely. So before we dive into the SageMaker suite of modules, I just want to first touch upon and set the stage on the different stages in a machine learning life cycle at a very, very high level, right? So we can basically divide the machine learning life cycle into 4 different stages. It starts with preparing the data, which is where you start preparing, doing a whole lot of data transformations and coming up with features for your machine learning model. The next stage is about model development. Again, you look at what kind of models to use, whether you are using models that are provided by SageMaker or building your own models. You kind of develop your model based on the business requirement that you have currently addressing. The third stage is about model development, as we know, is a very iterative process. So we need to train and tune the model in a very iterative manner. So this is where you start looking at tuning your models using hyperparameters. Right? There are a bunch of hyperparameters that are available per model, and depending upon the business objective, you tune the hyperparameter, and the objective metric, you figure out what is the best model to use to be deployed for inferences. And the final stage in this is about deployment and monitoring. Once the model is trained, tuned, and ready to be deployed, you need to deploy the model, but also start monitoring the model for any kind of model drift, data decay, and whatnot. Right? So this is at a very high level when we look at the 4 different stages of machine learning lifecycle. But where does SageMaker play a role in? Actually, SageMaker plays a role in all the 4. I know this slide is a bit loaded, but these are the number of modules that SageMaker provides in enabling the data scientists and the data engineers to start building their models and deploying them in production. Let me start with preparation stage. SageMaker ground truth is about labeling the data. When you want to use a data set for machine learning training, you have to label the data. So there is a service within SageMaker called ground truth, which helps you in labeling the data. And this can label not only structured data, but unstructured data like images, text, and whatnot. The next step within data preparation is about, next step in prepare is about preparing the labeled data for your machine learning purposes. SageMaker Data Wrangler, SageMaker Processing are a couple of modules within SageMaker which helps you prepare the data for machine learning. Data Wrangler is about more of a low-code, no-code capability where you can drag and drop multiple pre-built transforms that are available within SageMaker. So you really don't have to write any SQL code or Python code to transform your data. You can basically drag and drop inbuilt transforms within Data Wrangler. Now let's jump onto the build stage of it. Once, let's say, you've prepared the data set and your features are ready, now you are looking for the right kind of model to be built on the data set. So there are a bunch of ways that you can actually look out for models. The most easiest way is make SageMaker pick the model for your own use, which is done by SageMaker Autopilot, right? So think of SageMaker Autopilot as again as a low code, no code capability where you provide the data set, which is the features and the label, and SageMaker automatically identifies which is the right model for you to be picked for your model training purposes. If you're not comfortable with Autopilot, you could basically use SageMaker's inbuilt algorithms. SageMaker has close to 17 plus inbuilt algorithms that are available for you to use. Even further, if you want to take it, you can bring your own algorithms as scripts into the model building process. Right. Now let's jump onto the training and tuning. Right. When you start training the model, there are multiple automatic model tuning capacities, right? So you really don't have to identify the hyperparameter optimization. There are SageMaker modules available for hyperparameter optimization that are available for you to use. Right. While the model is getting trained and everything, there is always a level of visibility that you would require to see what is happening within the model. Are my gradients properly getting reduced? Are there enough, am I converging towards my loss or whatnot, right? So that's where SageMaker Debugger comes into the picture. SageMaker Debugger is a window into your model training process in itself, right? So now let's jump on to the last but not the least, the deploy and manage side of things. So let's say you've now trained the model, tuned the model, and the model is ready to be deployed. Again, SageMaker provides you with multiple capabilities to deploy it either as a batch transform or as an inference point or even on the edge. So there are things like SageMaker Edge Manager. We also integrate with Kubernetes and Kubeflow integration, and we have one-click deployments for both batch transforms and inference endpoints. In 2021 reInvent, we also introduced serverless inference, which means that you do not have to pay for inference endpoints for it to be always available. It is basically serverless. So when the call comes in, the serverless endpoint kicks up, and you can basically pay only for the calls that you make. Right? And there is SageMaker Model Monitor, which continuously monitors this entire deployment capacity for any kind of data drift and model decays. So at any point of time, the Model Monitor figures out there is some sort of a data drift or model decay, then it can basically trigger an automated retraining process using SageMaker pipelines. So as you can see, this entire SageMaker Studio is an integrated development environment, which brings together this whole complicated end-to-end model development and deployment process under a single pane of glass.
That's really useful and helpful, Meena. I think especially having everything built into SageMaker Studio, I think it's going to be a big game changer. Having said that, you talked a lot about the model and building the model and also optimizing the models and stuff. I wanted to get your thought, Meena, here on MLOps, right? That has been a term that I have been seeing customers use a lot with data ops, DevOps as part of it, right? So I have been seeing customers use this term MLOps. I wanted to get some help from you on trying to understand what MLOps is, and if possible, help how AWS is helping customers with this MLOps.
Absolutely. Yeah. MLlabs has been the buzzword for the last year or so, right? When machine learning came into existence or became very popular in the last decade, most of the machine learning focus areas were around building the models, but less on deployment of the models or managing the models and whatnot, right? So there was a Gartner report that came in 2021, which basically said that close to 50% of the models that are getting built by different customers will never get into the production stage because of the complexities in terms of taking the model into production, right? So this is where MLOps is very, very important. MLOps is the last mile within the machine learning space, right? So it is not about building the model that makes it drive value for the business, but it is about deploying the model and ability to manage the model in production and monitor it continuously so that we can gain the right set of decisions from the data. So it's about so in short, it is about bringing the best practices of software development, which is about the DevOps, into the machine learning space. So the machine learning integrated with the DevOps provides you with the level of automation, with the level of continuous improvement, and iterative way to manage your machine learning development lifecycle. This is about at a very high level, providing you a view of what MLOps is all about.
Gotcha.
So what is AWS doing in this space? So AWS, as I mentioned, has something called as SageMaker pipelines. Right? Think of SageMaker pipeline as a capability that can integrate different steps of your machine learning process into a single pipeline, and can be run automated with some sort of an event that triggers the pipeline. Right? Once the pipeline gets triggered, the model that gets generated out of the pipeline gets stored into what we call as a model registry. It is very, when you talked about the data lake and the data lake house, you talked about the importance of governance and security and ability to make sure that we have enough control over what we do within the architecture. So model registry plays a huge role in this space. Think of model registry as a single place for all your models that are getting developed within your organization, an ability to manage model versions, ability to manage data versions, and also an ability for you to approve the models that can go into production, right? So that is a very key component within your whole ML DevOps lifecycle, or the MLOps lifecycle. Finally, what we have is SageMaker projects. SageMaker projects, think of it as an umbrella, and AWS SageMaker provides you with templated projects for MLOps. So you really don't have to go and build your MLOps hierarchy within your project, but as soon as SageMaker projects provides you with templates, and all you need to do is use these templates, and SageMaker behind the scenes will build everything for you in terms of the pipelines, the model registry, and monitoring and approval mechanisms. Everything is encompassed within the project, within SageMaker projects. And there are multiple sets of templated projects available, and you can even build your own set of SageMaker projects if required. Before I close out, I just want to quickly show you how things work, right? So this is at a very high level, again, think of it as 1,000-foot level, right? So as I said, everything is encompassed within a SageMaker project, right? Within the SageMaker project, let's say you are running a machine learning effort, and your data scientist is building a model, or preparing the data and building the model and whatnot, right? All the code that the data scientist creates gets into a code commit, which is our Git repo for AWS. As soon as any changes that comes into the code commit, there is an event that triggers for the code build, right? So this is all the different stages in the model training process. We talked about data preparation, training, tuning, and whatnot to build the model, right? So all of these things are connected together using a SageMaker pipeline. At the rear end of it, the model gets generated and the model gets registered within your model registry. Now you can have some sort of an approval mechanism on the top. Again, this is optional, but we always recommend customers to do some sort of an approval mechanism before this model gets deployed into production. This approval mechanism, you can basically start looking at the explainability of the model. Basically, whether your model is responsible enough in terms of bias, fairness, and whatnot. And once it is approved, now it can be deployed back into production, right? And you can monitor it using a SageMaker pipeline, which we call it as a deployment pipeline. So this is again at a very, very high level how easy and simplified we can do the end-to-end MLOps lifecycle using SageMaker.
Sounds good. I think that kind of gives us a pretty good overview of how ML ops really works and how AWS can help with that. Thanks for that, Meena. I think, again, when you look back and when we tie both of what we had all the way from data analytics and data warehousing together, and our strategy of modern data strategy, where we said unify, modernize, and innovate, and putting what you just talked about, MLOps together, and also SageMaker Canvas, where we are trying to help the business with machine learning who do not need that machine learning expertise. I think we are having tools all the way from generation to all the way into predictive analytics, not just for engineers and people who daily work in and out of data, but also we have tools where business can start to see some insights into it with pretty much no expertise at all on machine learning. And we do all the drifting, or we do all the analytics behind the scene. We help with, especially with drifting, which I heard a lot of business definitely the day one, the machine learning models work really well, but 10 days in, they're starting to see that drift, right? So we have seen that happen, and really amazing how we have all the tools to get everything together. I think that's amazing, Meena. Ron, that's all we had.